Welcome to Mtari TV. In this video, we're going to learn about simple machines. Okay, so in today's video, we're going to learn about simple machines. So first thing first, we need to define what a simple machine is. So a machine is a mechanical device which uses an effort to overcome a load. So that is what a machine. So a machine is simply a mechanical device uses an effort to overcome a load. So we need to know the terms associated with the simple machines. So the first term we're going to learn about is what we call effort. Okay, so effort has a symbol E. It is represented by the symbol E. Then its SI unit is newtons, which is represented by capital letter N there. Then definition, effort is applied force. That's a definition of what effort and the simple machine. It's simply the applied force. That is what we call the effort. Moving on to look at what is a load. So a load is represented by the symbol L. Then its SI unit is what also Newton. By definition, a load is the force which the effort overcomes. So that's how we define what a load under simple machine. It's simply the load which effort overcomes. Okay, moving on, a load can be defined as the force of an object pulls or pushes on a machine. That's another definition you can use. If that the other one you've forgotten it or it's difficult for you, but I advise you go for the first one, which is simply said a load is a force which the effort overcomes. So moving on, we're going to look at what we call mechanical advantage. So mechanical advantage has a symbol MA, the symbol M dot A in capital letters. So the definition of mechanical advantage is simply the ratio of the load to the effort, and this formula is this one here. For you to find the mechanical advantage, you need to divide the load by the effort, as shown there. The one I've underlined with the red ink. So the SI units for advantage it doesn't have, because the ratio will cancel the units. The units will cancel each other out because they are ratios. So moving on, a machine with a greater mechanical advantage is more efficient than the one with a lower mechanical advantage. That's one of the things you should do. Take note there. Then moving on, we're going to look at the velocity ratio. So the velocity ratio, or the other name you can use, you can call it as the ideal mechanical advantage or speed ratio. The ideal mechanical advantage or the speed ratio. That's what we call velocity ratio, or the other name you can use for velocity ratio. So the symbol for velocity ratio is capital V dot R. So the best way to define velocity ratio is simply saying velocity ratio is the ratio of the distance moved by the effort to the distance moved by the load. So we're going to have that formula there for representing what the velocity ratio. So moving on, the SI units for ratio same applies to the mechanical advantage. The units will cancel each other because you're going to have this. They cancel each other because you're going to divide the same SI unit. Okay, so moving on to another point which you need to know is that the velocity ratio depends on the geometry of the machine and not on the friction. The velocity ratio depends on the geometry of the machine and not on friction. So efficiency of a machine, that's another term you need to know under simple question. So you need to know the efficiency of a machine. So the symbol is here for efficiency. Definition of efficiency. What is efficiency of a machine? So we simply define it as the ratio of the useful energy output to the energy input multiplied by 100%. That's how you define the efficiency of what? Of a machine. So moving on, let's look at the formula. So the formula you can use, there are about 3 of them, depending on the data you are given in the question. So yeah, this formula under what? Efficiency of a machine. So the first formula I can use is this one here, whereby you are given the energy output, you divide by the energy input. Of course, you multiply it by what? 100%. So moving on, the next formula I can use is this one here, whereby you divide the power output, if you are given the power in the question, by the power input. Of course, you multiply it with what? 100%, because you are dealing with efficiency, and efficiency is same as finding the percentage. Okay, that's how we are multiplying it by 100%. Then the last one you're going to use, you can use, depending on the data given in the question, is mechanical advantage is equals to efficiency is equals to mechanical advantage divided by the velocity ratio times 100%. So moving on, another important thing you need to note is that efficiency of a machine can never be more than 100%, because the energy output or the work done by the machine is never more than the energy input done on the machine. So what I'm trying to say here is simply that the efficiency of the machine, or the machine can never work at its full potential, because most of this energy will be lost, number one, to overcome friction, lost in form of sound. Some of the energy which you apply on that machine will be lost in form of heat, some in form of sound, some in form of what else? Yeah, the other one is used. Some energy can be used to overcome what? Friction. That's why the machine, or the efficiency of the machine, can never be what? 100%. So moving on, then another thing is that the mechanical advantage always will be less than or equal to the velocity ratio, and the velocity ratio will always be greater than the mechanical advantage, or equal to the mechanical advantage. I hope it's making sense. Generally, in an ideal solution, the efficiency of any machine is equal to 100%. In an ideal form, not in real life. Real life cannot work. Why? Because some of the energy will be lost in the form of heat, sound, and some of the energy will be used to overcome friction. Okay, so the idea of a machine working 100% efficiently is just theoretical. In other words, it's just done on paper, not in real life. Okay, so we'll move on. I'm sure we're done with the terms. Well, let's look at an example. Let's look at one example. Example number 2, which is this one. Find the efficiency of an electric motor that is capable of pulling a 50 kg mass through the height of 15 meters after consuming 30,000 joules of electric energy. Okay, so the first thing we need to get energy output. And how do you find the energy output? Energy output is equals to the potential energy. The formula you use to find the potential energy is the same formula you're going to use to find the energy output. In this case, energy output will be equal to mgh. Given our mass have been given in the question is this one here. Our gravity, we know that generally is what is 10 on Earth. The gravitational pull on Earth is 10, we know that. Then the height have been given in the question here is what is 15 meters. Okay, after correcting the data there, you plug in the formula. After you plug in the formula, you do this. After doing that, you multiply in. After multiplying, you should get something like that. Okay, so the energy input is this one given in the question here, saying that consuming 30,000 joules of energy. So after doing that, after finding those two data, you're going to use the formula for finding the efficiency, which is what? Energy output divided by energy input, of course multiplied by 100%. So we're going to get the 7,500 joules were found, and we're going to divide it by the 30,000 joules, and we're going to multiply it by 100% to get our efficiency, which is 25% when you've done the calculation properly, as seen right there. Okay, so move on. These are some examples, but due to time, it's the same concept. So now we're going to look at what types of simple machine. So the first and foremost, we have what we call the levers, the pulleys, the inclined planes, the gears, the wheel and axle, and the hydraulic machine, and the screws. So in total, we have about 1, 2, 3, 4, 5, 6, 7 simple machines. So let's look at what we call a lever or levers. So a lever is simply a simple machine consisting of a beam or a rigid rod pivoted at a hinge or fulcrum. That's what we call it. A lever, simply a simple machine consisting of a beam or rigid rod pivoted at a fixed hinge or fulcrum. It is a rigid body capable of rotating on a point on itself. It's capable of what? Rotating on a point on itself. The simplest form of a lever is a screwbar, but the term lever may be applied to any rigid body. About that space, to any rigid body which is pivoted about an axle called the fulcrum. Levers are based on the principle of moments. Levers are used to lift heavy weights with least amount of effort. Okay, so this is an example of a lever. You have the effort being applied there, which is here, and the load which is here. Okay, so we're going to use a formula which is distance from the pivot to the effort. So for you, under the levers, for you to find the velocity ratio, what you need to know is the distance from the pivot to the effort. Distance from here, where the force is applied, to the pivot there. You need to know that distance. And that distance you need to divide it by the distance or the load there to the pivot. That's how you find out the ratio under the lever. Some examples of levers: you have a wheelbarrow, crow hammer, table knife, scissors, borehole, cooking stick. All those are examples of what levers under a simple machine. So we have an example here under a lever, simply saying that study the diagram below and answer the questions that follow. So we need to calculate what the mechanical advantage, and we know that mechanical advantage is equal to what? Mechanical advantage is equal to load over what? Over effort. Look at the diagram there. What is our effort? Our effort is where the force is applied, and our load is what? This one here. So for you to find the mechanical advantage, what you need to do is simply divide 20 by what? By 60, which is going to give us what? 30, not 30 exactly, like 0 0 cancel. It's going to give us what? 3 as our mechanical advantage. That's how you find it. Then you need to find the velocity ratio. Of course, for you to find the velocity ratio, we need to know the distance where the force is applied to the pivot, which is there, and the distance from the load, which is this one to there. So looking at the diagram, our distance moved by the effort is what? Is this one. And the distance moved by the load is this one. So you divide 40 by what? By 10, which is going to give us what? 4 as your VR. It's going to give us what? 4. Then the next question is asking us find the efficiency. You simply divide this, the mechanical advantage, this is 3, by 4, then you multiply it by what? 100%. That's how you find your efficiency. So moving on to the next simple machine that we have on the list. These are some examples, but we're going to solve them in the WhatsApp group, not in this V, not in this H. So we have what called the pulleys. A pulley is a wheel with a graved rim mounted on the block. The effort is applied to the rope which passes over the pulley to change the direction of the force, and for the change the direction of the force and for producing a larger force from the small force. I'll show you examples of type of pulleys with single moving pulleys and broken tack pulleys. All these are type of pulleys. You simply put the rope there like that in that direction shown there. Then you apply the force here to this one. So that is what you call a pulley. So for you to find the velocity ratio, you simply count the number of wheels which a pulley has used. So in this case, our velocity ratio is 1 because it has a 1 wheel there. So moving to another type of a moving pulley, we're going to have this one here. The load is twice as the sun as the effort there, twice as the effort. So the same principle applies here for finding the velocity ratio and for finding for just the example here. So for you to find mechanical advantage, the velocity ratio. So for you to find the velocity ratio under this type of simple machine, simply count the number of rope. How many ropes are there? You have this one, 1, 2, 3 there, right? On the other side, you also have 3, 1, 2, 3. So the velocity ratio will be equals to what? Equals to 6. You simply count the number of lines which are in the middle here, or the number of wheels applied here. That's how you find what? The velocity ratio. For these examples, we're going to be solving them in the WhatsApp group. If you want to add for this PPT, you can box me on the number 077 42 33 555. Then we're going to do those examples together in the WhatsApp group, not in the video due to time and storage space. So moving on here, we're going to look at what we call the inclined plane. So an inclined plane is a simple machine that is used to raise a heavy load from the ground to a higher platform by way of putting the load then lifting it. So this is what we call an inclined plane. So the force which is pushing the object on top here, we call it what? As the effort. Then distance from where it's starting and to where it's going, we call that the distance moved by the effort. Then the load is simply the weight of the object being pulled. Then the distance moved by the load is simply the perpendicular distance to the to the load. Up there is clear. So for you to find the velocity ratio, you need to know the distance moved by the effort and distance moved by the by the load. The length of the slope divided by the height. That's how you find the velocity ratio. Or in other ways, you can use simply the inverse of sine theta, which is 1 divided by sine theta, provided that this angle which is here is given to you. Provided that this angle is given to you, that's when you can use the inverse of theta. So moving on, we're going to solve in the WhatsApp. this example will be done in the WhatsApp group. And the next thing you know is what? The gears. So a gear is a wheel which can rotate around its center and has equally spaced teeth around it. Gears transmit motion from one wheel to another. The driving wheel provides the effort, while the driven wheel is the wheel on which the load acts. So this is what we call the gears. So for you to find the velocity ratio under gear, you simply count the number of teeth in the driven wheel. You divide it by the number of teeth you first count the number of teeth in the driving wheel, then you divide it by the number of teeth in the driven wheel. So these examples we're going to do them in the WhatsApp group. So the next thing you need to know is the wheel and axle. So the wheel and axle, the wheel is fixed to the axle. The axle has a smaller diameter and the rope attached to it. It's wounded in the opposite direction to that of the wheel. The load to be lifted is attached to the end of the axle. Okay, so your axle there. So for you to find the velocity ratio of this type of simple machine, you need to know the radius of this one, which is small, and the radius of this one, which is big. So for you to find the velocity ratio, simply divide the radius of the small, which is the wheel. The radius of the wheel, you divide it by the radius of what is the axle. Again, the examples we're going to do them in So lastly, we have screws. So the screws here, the pitch of the screw is the distance between the two surfaces for threads, the turns of the rather. For one complete revolution, a screw moves through a distance equal to its pitch. So how do you find the velocity ratio on this type of a simple machine? We simply say 2 pi r, which is the radius over the pitch. Okay, where r is the radius of rotation of the effort. Okay, thank you for watching Mutare TV. I hope you have learned one or two things from this video. Remember, the examples on this video or the examples written in this book, we're going to do them in the WhatsApp group due to time and storage. So if you want to join the 3 for free, the online classes, you simply contact me on WhatsApp using this number. Then you'll be added on the group, which is 42 33 then 555 at the end, at the end. This is this is 4 here. Then we're going to solve those examples with the others who have already joined my WhatsApp group. Thank you for watching Mutare TV. Hope you have learned one or two things. Remember, we grow when you learn. We make physics simple.